Good morning, sixth graders. This week we are going to learn about freezing and melting. We're going to be concentrating on water molecules because that is a pretty common household piece of lab equipment, water. But we'll talk a little bit about freezing and melting of other liquids and solids as well. First thing I'm going to do is just show you my lab supplies. I have an old soup can here. If you have a soup can at home, yours is probably not as rusty as mine. I've just been using this year after year, and so it's a little bit old. I have put some duct tape around the top of it after I opened it up just to protect myself from getting cut, because sometimes that can get a little bit sharp. All right, I'm gonna add a teaspoon of salt into my container. Okay, add that in there. Just regular table salt, and this is kind of hard on the inside. And then I'm going to take some ice and fill the can halfway up with ice. And I have a little wooden dowel here. And mix that around a little bit. All I have in there is 1 teaspoon of salt and a half a can of ice. I'm going to do the same thing, put another teaspoon of salt in there. You don't have to be really accurate with your measurements. If you get a little more, a little less, that's fine. More salt. More ice. Get around a little bit. And we'll do the same thing one last time. I'm going to add more salt. And fill this up with ice. All right. Give this a little stir. Kind of hard to stir up, but do the best you can if you're doing this at home. You don't have to do it at home. You can just watch this video. Okay. We're going to let that sit just for a little bit while I show you some videos. Okay? Okay, so what we're studying here is what happens to molecules when they change from a liquid, like in condensation. When condensation forms on the outside of a glass, what happens when that condensation actually gets cold enough to actually freeze? And why did I add salt to the mixture? Why didn't I just put ice into that can? Well, I put salt in there because salt has a unique characteristic that lowers the freezing point of water. So what that means is it allows water to get colder than 32 degrees Fahrenheit before it freezes. And that'll just help our experiment a little bit. We'll talk more about how that works when we get a little deeper into chemistry. But salt is just an additive to let this happen more quickly. Okay? I'm going to show you just a couple videos. Now, we have definitely been talking about how water molecules will come close together when they are cold, right? So they take up less space when they are cold. But what about when they get so cold that they stop moving altogether? What is actually happening to those water molecules, right? We've got warm water. Warm water moves fast. There's lots of space in between them. They slip past each other. When they get cold, they slow down, they get closer together, and so they are attracted to each other again, and they reform into, they're in liquid water form, okay? If they get so cold that they stop their motion, they will stop in a fixed position and they'll form something that's called a crystal. Okay, we see crystals in a lot of different minerals, and you'll learn about those when you get into 8th grade. But water molecules, when they freeze in a precise arrangement. Think of a snowflake, okay? Snowflakes are frozen water, right? Frozen water, if you were to zoom in on the snowflake, those molecules are not just randomly arranged, they are lined up. And that is because of how water molecules are attracted to each other. Which atoms in the molecule are attracted to which other atoms in the molecule. Okay? So actually, this is kind of one of those things in science where there's an exception to the rule. Warm water is going to take up more space because the molecules are further apart. Cold water huddles together because there's not as much space in between. But then frozen water arranges itself in this like lattice crystal. And for that reason, it will actually take up even more space. So if you wanted to try this out, you could take like a little water bottle and fill it up with water, put the cap on nice and tight, and then pop that in the freezer and look at it the next day. What you'll notice is that the volume of frozen water takes up more space than the volume of liquid water. Alrighty? Let me pause this just for a second, and then I'm going to set you up with some animations.